Okay, so good day everyone. So today we're going to discuss about decoders. So there are different types of decoders according to its inputs and outputs. So we have a 2 by 4 decoder, we have a 3 by 8, 14 by 16, and other types of decoder. Okay, so today what I'm going to discuss to you is we have a we have a 2 to 4 binary, okay, binary decoder. So here that means that we have two inputs, okay, and we have four outputs. So our inputs here will be in terms of binary, and our outputs will be in terms of decimal. So if we're going to have a truth table for this one, okay, truth table, so we have inputs and we have also outputs. So we have, say for example, our inputs will be x and y, and your outputs will be represented by a, b, c, and you have d. So you can choose any letter you want to represent your output or to represent your inputs. Okay, so we have a binary inputs here. So you have 0 0 0 1, you have 1 0, and then you have 1 1. Okay, so these are binary inputs or binary values that if you're going to convert that into decimal, this would be equivalent to 0 1 2, and then you have 3. Okay, so your outputs here, a, b, c, and d, are being represented by 0 1 2 and 3. Okay, so therefore if your x and y will not be pressed, so therefore your a here, which is equivalent to your 0, is 1. Your b will be 0, c 0, and d is 0. Okay, or it's up to you if you're going to let your d as your 0 and your a is equivalent to your 3. It's up to you how you're going to design that one, but um here I'm just going to represent your a that is equivalent to your 0. Okay, next we are going to press y that is equivalent to 1, so therefore b is represented by 1, so that is 1 0 and 0. And then for x, which is equivalent to 2, so therefore c is represented by 2, that will be 1. And then lastly we have also your d, so your d is represented by 3. So whenever you're going to press x and y, therefore your d will turn on. Okay, so these are now your truth table. Now if you're going to use K-map, actually it's obvious already that there's no need for you to use K-map, simply because your outputs in each, or the ones in each of your output, is just only equivalent to 1. So there are no multiple ones in your output, so it will be easier for you to identify the equation. But if you're going to use K-map here, so say for example for a, we're going to use K-map. You have input x, you have input y, you have 0 and 1. Okay, you have also 0 and 1 here. So okay, so if you're going to press 0 0, so your a is equivalent to 1, and then if 0 1, that is 0 1 0 0, and then 1 1 is 0. Okay, if you're going to look at your K-map, so, or the table in your K-map, so the only ones here is only x bar and y bar. So therefore your a here is equals to x bar and y bar. If you're going to do the same for your outputs b, c, d, it will be the same. So if you notice here, your b here is 1. So if you're going to look at your x and y, okay, that is x bar and y. So therefore your b is x bar and y. For your c, the equation is you have x and y bar, and for your d, so you have x and y. So these are now the equations of your outputs. Okay, you have a, b, c, and d. So after this, we have already the equation what we're going to do, we're going to convert this one into schematic diagram. So to do that one, we're going to use the ProChew so that we can simulate the output and we will find out whether our equation is correct based on the given truth table. So let's proceed to ProChews. So this is now our ProChews. Okay, open it already. So the first thing what we're going to do is we're going to write the equation. Okay, so let's write the equation here. Okay, equations. Okay, equations. Okay, next, the equation of your A. Okay, A is equals to, you have x bar. Okay, x bar. And then you have y bar. Then the equation of your B. Okay, that is equivalent to x bar and y. Then the equation of your C is equivalent to x, and then you have y bar. And then the equation of your D, that is equivalent to x and y. Okay, so we have now the equation, so we're just going to arrange this one. So let's move this one here on the upper left. Okay, so we have these equations. Now, how are you going to identify now the components of your schematic diagram? Okay, let's try to know what are the inputs, okay, of your circuits, the process, and the output of your circuits. So here, our outputs, we have outputs A, B, and C, and D is represented by your LED. So we're going to use LED here to represent your output. Okay, now we have also X and Y as your input, and input is represented, we're going to represent that one by button. Okay, and then your process here, which is your the circuit or equation, so that will be represented by the integrated circuit, the ICs. It could be AND gate or not gate. So those are the components of your process. Okay, so we have the input, which is we're going to use button. Now we have the process, in which we're going to use the AND gate or not gate. And then we have the outputs, in which we're going to use LED for our outputs. Now, if you're going to look at the equation, so what particular component that we need to use? So if you notice that all our inputs, the X and Y, so we have a bar, so that means it is negated. So that means that it is inverted. So we need an inverter. Okay, that's the first thing. Secondly, that the X and Y are being multiplied, so that means multiplication is represented by an AND gate in the logic. Okay, so represented by AND gate. So next is that, okay, we don't have plus, so that means we are not going to use OR gate. So there are only two components in the equation that we need to use, the AND gate and the inverter. Okay, so let's try to find those components here. So we're going to look for the components, our component mode. We're just going to click this one and then click P for your devices, because we're going to pick the devices. The first thing to do is we're going to get the input, which is the button. Okay, just type button here. So this is now your push button. Okay, just double click to be included in our devices. The second is we need an inverter. You can type the word inverter, but okay, an inverter will come out, but we need to identify the specific IC number. Okay, and the specific IC number for an inverter is 7404. Okay, so just double click this one. And also we need to identify also the specific number of your AND gate, in which case the specific number or IC number of your AND gate is 7408. Okay, so this is now your 2-input AND gate. So why do we need to specify the IC number? Because when you're going to purchase these particular ICs in the store, You're not going to say you're going to buy inverter, you're going to buy an OR gate, you're going to buy an AND gate. But you're going to specify the IC number because they don't know the AND gate, they don't know what is an inverter, they don't know what is an OR gate, but they know the specific IC number. So you need to specify, or you need to tell them the specific IC number. Okay, so in AND gate we have multiple input AND gates. We have 2, we have 3, 4, so on and so forth. But what we're going to use right now is we're going to use the 2 input AND gate. So for other inputs, like for example, you have 3 inputs, 4 inputs, 5 inputs, every difference in that in inputs will also create a different IC number. Okay, so a 3 input AND gate has a different IC number also with 2 inputs or 4 inputs AND gate. So in the 2 input AND gate, the IC number is 2408. So just double click this one, okay, to be included in your devices. And then we also need a LED. So we're just going to type LED. Then we're going to select, okay, the color. It's up to you what color you wanted to select. Again, double click. Again, another thing, we're going to use a resistor for our inputs, because we're going to create a circuit for our push button. Okay, so just double click, okay, and then we're going to close this one. So these are now our components. So the first thing, we're going to select the button. So we have 2 buttons here, the X and Y button, in which these buttons will be connected to the ground. So we're going to have a supply here by clicking the terminal modes, then select ground, okay, and then you click it here, then connect this one to the ground. Okay, next we're going to click this one, power, because we're going to connect this one to our resistor and to the output of your push button. Okay, so we need a resistor, this one. Now take note that this is a 10k resistor, so we're going to adjust the resistance to a smaller value, say 1k. Okay, and then we're just going to rotate this one. Okay, then move. Okay, then we need another one resistor for the other button. So this one is 10k. Again, we're going to adjust this one to 1k. And then again we're going to rotate and then move it here. Okay, then we're going to connect this one to the power, and this one will be connected to the first resistor, this one to the second resistor. Okay, so we start with the first equation, your A. So therefore your X bar and Y bar are all ANDed. So take note, it is being negated, so we need an inverter. Okay, so this one. Okay, we need to invert your X and Y. Okay, we just move this one here. Okay, then this will be ANDed, so we need an AND gate, 7408. This will be our first output. Okay, so this will be X bar and this will be Y bar. Okay, this is the first output. That is equation A. The next is equation B. So B is X bar, this one, and that is ANDed to your Y. Okay, X bar and Y. That's the second output, that is equation B. Equation C, the third output. So that is X. So we're just going to tap it here, or say for example here. This will be your X and your Y. No, that's Y bar. So we're going to tap it here. Okay, that's for C. And the last equation will be your D. Your D is X and Y, so we're going to tap here X. Okay, and we're going to tap here for your Y. Okay, So these are now your uh, outputs. All your outputs will be connected to your LED. Okay, so we need a LED. Where's the LED? So here's the LED. Okay, so click it here, and then we're just going to rotate this one. Okay, then since we have 4 LEDs, so we're going to copy this one. So copy. Okay, then paste. Okay, so and then paste, then paste. Okay, okay, next we're going to connect now our outputs to your LED. Okay, okay, so out connecting these two, and now all your outputs or all your other uh, side of your LED will be connected to your ground. So we're going to get ground here. Okay, just click it here and then connect it to the ground. Okay, so this is now your circuit. Okay, the next thing we're going to do is we're going to label. Okay, we're going to label this one. Say this is your X. Okay, this is your Y. Okay, this is your A. This is your B. This is your C. Okay, this is your D. Okay, this one is 0. This one is 1. This one is 2. And then this one is 3. Okay, and also don't forget our truth table. So we're just going to put a truth table here at the side. So truth table, and then we have also inputs, and we have also outputs. Okay, outputs. Okay, let's arrange this one first. Okay, this is A and this is B. Okay, this is C. This is D. Okay, this is 0. This is 1. Okay, this is 2. This is 3. Okay, then you have here X, and this is your Y. Okay, now let's arrange this one, your truth table here. Okay, and then you have inputs, you have also outputs here. Okay, so again, let's try to put our inputs. Okay, your inputs are represented by your X and your Y, and then you have A, B, okay, C, and then we have D. Okay, so next we're going to do, again, we're going to arrange this one first. So you have X here as your input and your Y here. Okay, now your output will be A, and then you have B, and then you have C, and then you have D. Okay, these are now your outputs, and then let's put a number here. So you have 0. Okay, you have, okay, let's just copy this one. Okay, so we put 0 here, And then what we're going to do, we're just going to copy so that it will be easier for us to paste this one. Okay, so one. Okay, paste. Okay, paste. Okay, paste. Okay, next we're going to copy all. So just going to copy this one. Okay, copy. And then paste. Okay, paste. Okay, and then paste. Okay, so what we're going to do next, we're just going to edit this one. So this one will be 0, this one will be 1. Okay, that is 1. This one will be 1. Okay, and this one will be 1 also. So 1 and 1. And for your A, this will be 1. For your B, this will be 1. For your C, this will be 1. And lastly, for your D, this will also be equivalent to 1. Okay, so this is now your truth table. Then let us see whether our schematic diagram and our simulation is correct. So let's play this one. Okay. Okay, so if you notice that, okay, so your number 3 is turned on. Okay, so supposedly your 0 or your A should be the one to be turning on, not your D or your number 3, because we did not press anything yet. So that means 0 0 your Y, X and Y, so therefore your A should turn on. Okay, so let us check the other buttons. Let me see. If you're going to press, okay, first thing in your truth table, you're going to press Y. So if you're going to press Y here, okay, your number 2 will turn on. Okay, now how about if you're going to press X? If you're going to press X, your B will turn on. Okay, if you're going to press the two buttons, okay, your A will turn on, or this equivalent to 0. So if you notice that the output is reversed, okay, the output is reversed. So how are you going to reverse also the output in this case? So to do this one, what you're going to do is we're just going to invert your inputs. Okay, invert your inputs. We're going to have a double inversion here. So let's try to do that one first. So this end this one. Okay, stop the simulation, and then we're going to put inverter in between. Okay, so what we're going to do, we're going to put an inverter, okay, in between your button and your inverter. So we're going to have a double inversion here. So let's delete this one first. Okay, this one. Okay, so let's put an inverter in between. Okay, so next we're going to select an inverter. We're going to put it here. Okay, and also here, the other one is here. Okay, and then we're going to connect this one here, and also this Y, and this is your X. So we're going to connect our X here. Okay, so let's check first. Your first equation, you have inverted X and inverted Y. Your second equation will be inverted X and Y. Your third equation will be X and inverted Y. And for your last equation will be X and Y. Okay, so let us check this one if this is correct. Okay, so if you are going to turn it on or you're going to play this simulation, so looking at the outputs, so A should be turned on because we're not pressing any buttons there. So that means that the inputs are 0, 0. So A is represented by a decimal number equivalent to 0. Now if you're going to press Y here, so supposedly your B should be turning on. That will be 1. Okay, so that's correct. And if you're going to press C or X, your C should turn on. Okay, that is represented by 2. That's correct. And if you're going to press the 2 buttons, your D should turn on. That is equivalent to 3. Okay? Okay, so that's correct. So if you notice, our outputs now are all correct. Okay? So we just do the double inversion. So take note also of the blue and red colors in your circuit diagram. So blue is represented by 0 and red is represented by 1. And there's another color there. There is a gray color. A gray color is a it is neither 1 or it is 0. So in most cases that is actually there's no connection to it. That is why it is turning gray. So here this is a logic subject, so therefore you need to be logical in terms of understanding and analyzing the flow of your values, especially the ones the zeros here. Okay, so you will understand that later on when you are going to have a complicated circuit. So it's important to know if when it will become 0, when it will become 1, and you will know that 1 in your circuit during simulation because there's a color coding for ones and zeros that is equivalent to red and blue. So blue is represented by 0 and 1, or red is represented by 1. Okay, so that is now our schematic diagram and our simulation for our 2x4 decoders. So later on I'll also be discussing to you the other types of decoders. And if you have questions, clarifications regarding to our topic today, so kindly message me in our LMS or you can have your questions during our collaborations. Okay, so once again, thank you for your time and thank you for listening. Have a nice day, everyone. Good day and God bless.